Hello, my name is Ramon. I'm studying at Austin University, currently attending the Network Automation course given by Horst Baumann. As part of the Network Automation course, we had to solve an exercise or a project, a lab, to automate layer 3 service, VPN service provisioning in a given service provider network. Actually, the topology is depicted on this image here. So we have two core routers, and we have 4 edge routers, and edge 03 and edge 04, they are just individual customer sites, like single homed, and edge 01 and edge 02 are connected to a switch, so that's a multi-homed site. And then we have Linux servers connected. Those are just the customer systems actually configured with a static IP address. And in this case, 01, like the machine here would be from customer A, and then that one below customer B, and they are split up with they're in different VLANs basically, yeah. And then here, just for each port, there is a different customer. So the upper one would be customer A, the lower one customer B, and the same applies down here. Alright, and the configuration, that one will be done based on a predefined services YAML file. So I'll just quickly look on that. We have a YAML file which defines a list of services. In this case, we have the properties name, for example, that's for customer A in this case. And that one will be set for as a VRF name and so on. So we have an ID, we have a description, we have route targets defined, and we also have site-specific information. So customer service would be deployed or provisioned at multiple sites. So this is then again like a per site definition of required interface configuration. The same here for customer B. We see that customer B is only active at site A and site B, and customer A is here, site A, site B, and site C. Okay, currently no services are configured on the network, so let's go ahead and just run the Ansible playbook. We'll see what it does, and then we'll just configure these two, the customer A and customer B service. So for that, I have a shell open here. I already started my virtual environment where I have the necessary Ansible utilities installed, and I just run the playbook, which will start with gathering facts. It will back up Cisco device configuration, and just maybe scroll down here a little bit. Then we will retrieve like the primary loopback interface configuration, because that one will be required as part of the route distinguisher. We'll just extract the IP address here. That's just some preparation stuff. And then we get the list of customer VRFs we need to configure. The customer VRFs variable is initialized, so all like preparation. And then we go to the configuration part. We add the customer VRFs. We all, like for this configuration steps, the Cisco iOS module is used. And inactive VRFs are purged. In this case, nothing was done because we just added 2 new VRFs in this case, and 2 new services, and none was removed. Then BGP is configured, like the address families are added to redistribute connected routes. And then VRF interface configuration of the IP, we set the IP address on single home routers, and then we're gonna do some stuff to get the multi-home router configuration that includes HSRP configuration and that kind of stuff, and also like figuring out the virtual IP. And then we configure those multi-home routers, we configure HSRP, and then we're actually done, because this step is skipped. We don't want to remove all the services. That's yeah. And then finally, the configuration is saved to the running config is saved to startup config. So now that worked. We're just gonna quick look at the configuration. We see some log output that Ansible was active here, This is H01, so that's a multi-homed device. We can also see that here. Like we have some HSOP output, and we see this one is the standby device for both group 20 and group 10. So if we look at the running configuration, we now see that there is like a VRF definition for customer A with the route distinguisher set for the loopback 0 interface, so the primary one, that one which is used to establish BGP peerings and so on. And then we have a VRF customer B definition, that's all good. We have some general Cisco default specific stuff here. Then we come to the interface configuration. Here, some of those are just used for the underlay network, so configured with OSPF and that kind of stuff. But then, for example, here we got 4.10, so that's subinterface, .1Q for VLAN encapsulation. And here we have VRF customer A defined, or the VRF, that interface is part of that VRF, and we configured the IP address which is set in the services file. Yeah, and that applies actually to, that was done on all routers, like specifically based on that configuration in the services file. It's just an example now on H01. And yeah, what else we need to look at? In this case, also the BGP configuration was modified of this autonomous system 65000. And we have the address family for VPN v4, which is activated by default, but we added then this IP version 4 address family for those specific VRFs, in this case VRF customer A, we redistribute connected addresses, and also for customer B. Okay, that's it. Those are like the configuration changes which were applied by Ansible to this router. And now we're just going to quickly confirm that it's also working. So we have 4 terminal windows open here, 4 SSH sessions. On the right hand side, those are the 2 servers connected to site A. So the upper row is customer A, the lower row is customer B. And on the right hand side, here we have the server from customer A connected to site C. And that's the server of customer B connected to site B. So let's just quickly do an interface listing here, just to confirm that you see, like based on the service definition, which service those are. And now I'm gonna run a ping from the right side, from the right servers to the left servers, as it is also in the topology. And on the left side, I just run a TCP dump session to see if the ICMP packets are actually received. So we're just going to do this. We see on the left side, right, we got some ICMP echo request replies from the specific server. So that works for both service A, service for customer A, and service customer B. So now I'm just going to remove customer B. So just going to comment this out in the service file, save it. And currently no configuration was modified, so it's just a service file which is updated. But now we're gonna apply this via Ansible, run the playbook again, and that will go through the whole process again. It will skip a lot of steps, so it's basically always like things which are already satisfied. But an important step here is like the purge operation of inactive VRFs. So we see that on H01, 02, and 03, where like they were modified, the VRF of customer B was removed, and H04 was not modified. That's because no site is customer B is not located at site C. So site C is in the responsibility of H04, and because customer B is not located at site C, there was nothing to do for H04. Alright, so that seemed like it worked. We can just quickly confirm that we have now host unreachable messages. So for customer A, everything works fine. For customer B, it stopped working here. We have destination host unreachable messages, which is expected. And if we quickly look at the configuration of the router, show run, and then we see that there's no more VRF definition for customer A. There's only the VRF definition for customer B. So that was a successful change. It also applies to the address family configuration and the interface mapping. So yeah, That's it. So if you look at this one, there is no more VRF forwarding enabled for this interface. Okay. Now some details about the Ansible playbook, or how this is set up. The service file you already are aware of. We're gonna quickly look into the inventory right now. So here we got network hosts. So like this inventory is built to be like extensible. So if you want to use this Ansible solution for the whole infrastructure, we could also have Linux servers in there, but like here we have a dedicated group for networking, so that will be split up then. And then we have like the core and edge routers. The core routers are actually not required to be in here for this layer 3 service, VPN service deployment provisioning, because the core routers are already pre-configured, like MPLS and OSPF underlay. They are pre-configured already, so I could remove this and it will still work, but it's just in here for completeness. And then we have the edge group. This is an important one because that one is selected by the playbook, so as a target group. And here we split up again into multi-home and single home because these routers need a slightly different handling. And the only variable actually we define for each of these routers or hosts is the Ansible host variable, and we set it to the destination or the IP address of that specific host. Other variables are set inside the host vars. So host specific variables for Edge 01, for example, are configured inside here. Here we just define on which site the router is located at, and also like HSRP specific configuration parameters are configured here. Edge 03 and 04 only have the site configured because site variable, because they are single home, then they don't need HSRP configuration. All right. That's it. For groups, I don't have any group vars, so I could actually also remove that. Then the playbook itself, that's all. It actually just includes the L3 VPN role, which we can take a look at, and it selects the edge group as I explained earlier. Okay, first we're gonna start with the variables here. We just have the primary loopback interface specified. It's just the interface used for to do BGP peerings, and this will be like the IP address of this interface will be used as route distinguisher. And then we have BGP AS number specified. That's just the AS number of that local autonomous system of that service provider network. In this case, it will be 65,000. And then we have some defaults, like those below here we already discussed. That's like host specific. Those are host specific variables and need to be set in the host vars. Then up here we have connection plugin specific settings, which applies to all Cisco routers. And then we have the service file, the path to it, and we have default VRFs defined as a list here. So we just defined the VRFs which should not be touched by the automation. Yeah, that's basically it about this. And then very important is the tasks folder. It is like split up quite well. Here we have the main YAML file, which includes those tasks based on some conditions. So the prepare task, it is executed at any time, so it's just gathering facts and set all the information required to do the layer 3 VPN configuration. And then we set up customer VRFs if we have services defined, and we set up the BGP if services are defined. And also here, like for single home routers, and if services are defined, we configure the uplink interfaces, and we do the same for multi-homed. And then we just include a specific file here. Yeah, and then we do attempt the HSRP configuration if multi-homed and services are defined. And in case no services are defined, we remove all layer 3 VPN services, which will be this task here. And finally, the running configuration is saved to startup configuration. I won't go into much detail on this or into any detail. The code is made public, so you can then just look into these yourself. It's just actually the usage of this Cisco iOS model and some set facts and that kind of stuff. All right. Then Yeah, that's it actually. I'm just gonna show you what happens if you have an empty service definition, and then that would actually be the end of the Ansible demonstration. So I just have now an empty service definition. I'm gonna just execute this again. We get all the information like prepare step, and then like actually all the steps here are skipped because those have no relevance for the deprovisioning of that services. It could be an error, like by mistake, that the service file is empty, or we specified something wrong, and we don't want to just remove all services right away in case of that. So the script will ask to confirm if we really want to do this, and then yeah, just press enter, and it will remove all customer VRFs and will save the running configuration. And now, if I open up the terminal here, no more requests are going through. That's just like now in timeout as well for customer A, customer B anyways, as it was before. And if we check the configuration here on the router, I need the router here, then we will have no more VRF configured on this. So just the management VRF is still here, but no more customer A nor customer B. All right, thank you very much for your attention on this. I hope you liked it and have fun automating your network.